So let's consider another function right here. We want to find the critical numbers, if any, of the function. We want to find any open intervals over which the function is increasing or decreasing, and then apply our first derivative test to identify all the relative extrema. Now, this is where you want to be able to use our definition of the absolute value. We know that we're dealing with the absolute value of x minus 5, and that the absolute value of x minus 5 itself can be rewritten in two ways depending on the value of x's that we're substituting in. The absolute value of x minus 5 is simply going to be equal to itself whenever x is greater than or equal to 5. And you know that because if x minus 5 is greater than or equal to 0, then x has to be greater than or equal to 5. Or it's equal to its opposite, so the negative of the quantity x minus 5, whenever x is less than 5. So in fact, what we're going to do is we're going to find that f of x is in fact a piecewise function that can be divided up into two pieces. The first piece being 5 minus the quantity of x minus 5 whenever x is greater than or equal to 5, and we can make it 5 minus the quantity negative of x minus 5 whenever x is less than 5. Well, this is a bit of a complicated bit of function to deal with, so let's rewrite it one more time. F of x is actually equal to 5 minus x plus 5, so that's 10 minus x whenever x is greater than or equal to 5. And the function 5 minus negative x minus 5 is the same thing as 5 plus x minus 5, so it's just equal to x when we simplify it whenever x is less than 5. Now, how is this helpful? Well, we know that at x equals 5, the derivative will not exist. Why? Well, the answer is that change in behavior. We know that to the left of x minus 5, it's as though we're trying to tell you that f prime of x is equal to negative 1, because if you took the derivative of 10 minus x, you'd get negative 1, whenever x is greater than 5, and f prime of x would be equal to positive 1, which is the derivative of just y equals x. And this would be true whenever x is less than 5. What actually happens at 5 is undefined, right? So f prime of x does not exist at x equals 5, and that's our critical number. Okay. So what could we say? Well, if the critical numbers occur, in this case, at x equals 5, and no place else, it's a critical number, by the way, because f prime of 5 is undefined. Then what could we say? Well, let's take a look at the derivative. F prime of x is equal to negative 1, we said, whenever x is greater than 5. That implies that the function is decreasing on the interval that goes from 5 to infinity. But f prime of x, we said, would be equal to positive 1 on an interval where x was less than 5. We would interpret this to say that the function is going to be increasing on an interval that starts at negative infinity and goes to 5, but of course doesn't include 5. And so what do we know about this kind of function? Well, if the function changes from decreasing to increasing at a point where a critical number occurs, if the function is continuous at that point, and this function is continuous at x equals 5, then we say that the function has a relative maximum. And in this case, that relative maximum occurs at the point 5. Substitute in 5 in the original function, 5. And that's what we would look for in our function's derivative and this first derivative test.